you can trust or believe in the correctness of the data sets. The data sets are correct, which is called as the fidelity. Black box is everything is hidden and nothing is shown outside, isn't it? Whereas fidelity can be calculated by these four parameters: A plus D divided by B plus C. In a second stage, what we'll do is a neural network is used to predict the errors. Hello students, welcome to the next session of Cloud Computing and Big Data Analytics. Let's start this session with some more concepts of the neural networks. Okay, in the last session I told you about the basic concepts of the neural networks, how we can use the multiple neurons or neurons to perform the or process the or analyze the data. Let's know some more about the neural network in this session. Okay, the training set that is used here to estimate the weights. What is the priority of the value or the value of or weight of a value or weight of an input variable in calculating the output variable or getting output variable? How much is the importance of a particular input variable is called as the weight of that variable. So we use a training set to estimate the weight of a variable, and the validation set is again an independent data set. Validation set we get with the implementation of the optimization algorithm will be an independent data set that is used to decide when to stop the training of the values. Okay. Another scheme to prevent a neural network from overfitting is weight regularization. That is, the idea is to keep the weights small in absolute sense. The priority will be set to minimum because otherwise they may be fitting the noise in the data. Unnecessary data may be added because of the weights on that values. This is implemented by adding a weight size term. What is the weight of the value will be added to the objective function of the neural network. We use the objective function for the neural network. Although neural networks have their merits in terms of modeling power, they are commonly described as black box technique. Black box is everything is hidden and nothing is shown outside, isn't it? If it is a white box is nothing but the transparent box where the values will be visible to the algorithms or data sets are visible. Whereas black box techniques are making the inputs invisible. Okay, because they relate the inputs to the outputs in a mathematically complex, non-transparent and opaque way. They relate the inputs to the outputs which is not visible to the other algorithms or other set of values. They have mathematically complex, non-transparent and opaque way of relating the input to the output values. In application areas where interpretability may not be required, you need not to interpret the values, that is doing the fraud detection or response modeling, they can be very successfully adopted as high performance analytical tools. We can use the neural networks to analyze the data more efficiently when there is no need of interpretability. You need not to interpret the values. You just use the neural networks to build the relationship. The purpose of rule extraction is to extract if or then, if happens this and then what happens. So classification rules which mimic the behavior of the neural network. Okay. Two important approaches we can use for the decompositional and the pedagogical technique we can use to rule extraction, the extraction of the data. Okay. So decompositional rule. First one is the decompositional rule. It approaches the decomposing the network's internal working. How does the data is distributed in a network? By inspecting weights or activation values. So to check the weights of the value, we use the decompositional rule. A typical 5-step approach for the decompositional rule is: first, train a neural network, use the training set, and churn it or decompose it as much as possible in terms of connections. Only minimum connections are there. Till then, you have to decompose the values. Categorize the hidden unit activation values using the clustering. Using clustering algorithm, you have to categorize the hidden values. Extract rules that describe the network outputs. Extract the rules that describe you or give you the description of the network outputs in terms of the categorized hidden unit, in terms of the units that are categorized or made into clusters. Okay. Then extract the rules that describe the categorized hidden unit activation, which categorize the hidden, the one which is visible and another which is hidden. In terms of the network inputs, this is in terms of network outputs, the values which are not hidden. The hidden values will be in terms of network input, because inputs are not visible, they are hidden in the hidden layers, isn't it? Merge the rules obtained in step 3 and 4 for output as well as for input to directly relate the inputs to the outputs. Now we can relate the inputs to the outputs using the rule extraction method. Okay. Note that the step 3 and 4, both extracting the input and the output, can be done simultaneously at the same time by building a decision tree. You can build the decision tree over the set of values, relating the network outputs to the hidden unit activation values. To make a hidden unit activation values, we'll give a diagram which gives the example of applying a decompositional neural network rule extraction approach in a credit scoring setting. Here we have a diagrammatic representation. We have the customers, their age, their income, gender, and what is the response. Start from the original data. This is the original data we get. Step 2 is build a neural network. Example 3, hidden neurons we get. Customer, age, income are there, gender are there. We get 3 hidden values, H1, H2, H3. We give the values, that is hidden neurons. We'll give the weights for each of the values and the response given by each of the customer for a credit scoring. Okay, we'll give the credit score which are hidden, H1, H2, H3. 3 hidden neurons are given. Categorize the hidden unit activation. If H1 is 1 and H2 is 3, if and then condition will be applied, then response is no. You can have a neuron. If H1 is 1 and H2 is 3, then response is 1. Okay, like this. This is the first condition. If H2 is 2, then response is yes. So if it is 1, but the H2 is changed, then it will be yes. Step 4 is extract the rules relating network output to categorized hidden units. We'll use the hidden units, that is the H1, H2 and H3, to extract the rules for the relating output. These are the outputs. See, these are the outputs, H1, H2, H3, credit scorings. They are extracted using the categorized hidden units. And then we use the extract rules relating the categorized hidden units to inputs. Okay, this is about outputs. These are the inputs. Who are the inputs? The customer name, age, income, gender, these are the inputs. We make the extraction rules for the inputs. If age is less than 28 and income is less than 1000, then H1 equals 1. If age is less than 28 and income is less than $1,000, then H1 will be set to 1, credit scoring. If gender is F, if it is female, then H2 becomes 3. So we get the output by extracting the rules with respect to the inputs. These are the inputs, isn't it? The age, gender and income. Okay. Final is merge both rule sets. So if age is less than 28 and income is less than 1000 and gender is F, then response is no. If age is less than 34, income greater than 1500, then response becomes yes. Okay. So decompositional approach will be written like this for neural networks rule extraction. Okay. The next figure that we have shown here gives an example of applying a decompositional neural network rule extraction, extracting the rule approach in a credit scoring setting. Same thing with an advanced sets. Okay, here we have that example. So if credit term is greater than 12 months, what happens? If purpose is case provisioning, if purpose is second-hand vehicle or saving account is greater than 12.40 euros, income is greater than 719 euro, property is no, years of client is greater than his client in the same institution for greater than 3 years, and economical sector is sector C, that is below economical, then what has to be done? Whether you have to decide it, applicant is good or applicant is bad. So these values will be given for the decomposition rule extraction approach, which gives the values both for applicant good and applicant bad. Okay. Here we have the different conditions. If term is greater than 12 months, loan term, and purpose is cash provisioning, and saving accounts has deposit less than or equal to 12.40 euros, and he is a new customer. That means he has only less than 3 years of introduction to your bank, then the applicant is considered as bad. If the condition is bad or the applicant is considered as bad, credit scoring may be less, isn't it? So like this, we can conclude with these values, how you can get the conclusion or the output from the inputs using the neural networks rule extraction procedure or rule extraction approach. Okay. Then we have the pedagogical rule. How does the pedagogical rule is used? Extraction techniques in pedagogical rule consider the neural network as a black box and use the neural network predictions as input to a white box analytical technique. Okay. So we use the black box and uses the neural network prediction algorithms or predictive analytics as input to a white box analytical technique, which are decision trees. So in decision trees, every value is visible and transparent, isn't it? It is called as the white box technique. Okay. Here we have the representation of the pedagogical rule that you can use. We have the customer, same set of customers with the network prediction. We are adding the network prediction in the pedagogical rule. The network prediction is no, yes, yes and yes for all the other three. Okay. So step 1 is again start from the original data. Step 2 is build a neural network for different independent variables as well as the dependent variables. Step 3 is get the network prediction and add them to the data set. You can add them to the data set. Extract the rules relating network prediction to original inputs. We can extract the network prediction with the network original inputs, generate the additional data where necessary. Here we use the decision tree in a pedagogical rule, which is transparent, which is called as the white box technique. Okay, we use the same network tree or decision tree to come to a decision whether a customer is good or bad. Okay, this is the example of the pedagogical rule in the data extraction. In this approach, the learning data set can be further augmented or further extended with artificial data. You can artificially input the data, which is then labeled. They are then labeled as classified or predicted. They are already classified, or simply they are predicted values by the neural networks. You can predict the values in the neural networks so as to increase the number of observation. What is the total number of observations? To make the splitting decisions, to make them splitting when building a decision tree. How do you extract the values? That can be viewed like this. When using either a decompositional or pedagogical rule extraction approaches, when you use one of it, the rule sets should be evaluated in terms of their accuracy. We use the rule sets which are evaluated in terms of their accuracy, how accurate the data they are going to give, conciseness, how minimum number of rules and number of conditions will be applied by the rule sets, and fidelity, how much fidelity it has, how much trust it has, and that means it is, you can trust or believe in the correctness of the data sets. The data sets are correct, which is called as the fidelity. The rule sets are evaluated in terms of these parameters: accuracy, conciseness, and the fidelity. Okay, the conciseness and the accuracy are the measures to what extent the extracted rule sets perfectly copies or take the repetition. Exact data set is taken with the neural network and is calculated like this. So, rule set classification, good or bad, use the good grades A and C, bad with B and D. We use the predictions using the accuracy and the conciseness, whereas fidelity can be calculated by these four parameters: A plus D divided by B plus C. So, it is important to always benchmark the extracted rules or trees with a tree built directly on the original data. The decision trees are usually built on the original data that is corrected, but whereas the neural networks are extracted or neural networks are built over the dependent and the independent variables. Okay, so we use the extraction rules or trees with a tree built directly on the original data to see the benefit of going through the neural network. What is the benefit of using the neural network? Can be viewed by directly building the decision tree over the original data without any processing or any decomposition. Another approach to make neural networks more interpretable is by using a two-stage model setup. We use two-stage model setup. What is the idea between this two-stage model setup is to estimate an easy way to understand the model. To understand a model, final model, you have to use a two-stage model setup. Okay, this will give us the interpretability part. So, you can easily interpret the data sets using that approach. In a second stage, what we'll do is a neural network is used to predict the errors. It is used to predict the errors made by the simple model, which are made by a simple model using the same set of predictors. We use the same set of predictors to predict the errors in the collected data, erroneous data. Both models, that is two-stage model and a single model, are then combined in an additive way like as we shown here. We use the target with linear regression, that is x1, x2 to xn set of independent variables plus implementing them in the neural network. We use the set of values. The score can be calculated using the logistic regression model with the same set of values. Here we have a setup which provides an ideal balance between the model interpretability and the model performance. How does you can get the response and set of data. First step is again start from the original data. Next we have build a logistic regression model over the original data that you have received. Like we get the regression model, no, yes, yes, no. Based on the binary values, we get logistic regression. We get on these responses based on different input conditions. Then we have step 3, calculate errors from logistic regression modules. What is the error percentage in this? Error of the values, input values. That will be taken as the errors. The step 4 is building a non-linear predicting errors from the logistic regression model. We will get a NN in output from the errors. Error percentage we get. So final output is this. So score new observations. You can score new observations by adding up the logistic regression and the NN scores. So build a nearest neighbor. NN stands for nearest neighbor. Build a nearest neighbor predicting errors from the logistic regression model, knowing the nearest neighbor values. So you have to find out the errors in nearest neighbor values, then score new observations by adding up the logistic regression as well as the nearest neighbor scores. So this is the nearest neighbor output. Okay. So this is how you can extract the values and you can analyze the different values in the neural networks. So this finishes with the neural networks. In the next session, we shall come up with other type of analytical algorithms. Okay. Thank you.